I'll just give you some problems and you can tell me how to do them. We'll do the easy lifting first.
Subtract the 5n, add the 9, divide by 2.
So I tell you what, tell me what the second line should read. You don't actually, I know you know algebra pretty good, so you don't need to tell me what you're going to do. But if you can give me the second line.
2n equals 20.
Okay, so really the 20 is going to be over there, right?
I just like having my variable on the left side.
Okay, nothing wrong with that. Obviously, if 20 equals 2n, then 2n equals 20. Okay, and n equals 10.
Yeah.
All right, let's do another one. And you can do it step by step, however you want to do it. You don't have to give me the final line to this equation. Let's do the first step.
That'd be 12x minus 20 equals 2x minus 16, or minus 22x actually, if you combine like terms.
Hold on, what's the last term?
Minus, oh, never mind, minus 6x.
Yeah, that's a good second step. Don't try to do too many steps in one.
All right.
Okay, now combine like terms. Put all the variables on the left side if you like, all the numbers on the right.
You're going to end up with 16x plus equals 4.
Good. Okay. Here, tell me what your first step is going to be.
Not sure.
Well, when you have an equation that has a lot of denominators, especially a lot of different ones, if you can take one step and get rid of all the denominators at once, that's a great step to take. What can I multiply the left and the right side by to make all my denominators disappear? It's the least common denominator that you're looking at.
Least common?
So what's the least common denominator with 3, 4, and 6? In other words, if I gave you this problem, how would you add those three fractions together?
Add the denominators.
What's the least common denominator? In other words, you can't add them together until they all have the same denominator.
13.
How much?
13.
That's an interesting guess. Because
I don't know.
But you don't add the denominators. In other words, when you're trying to come up with a least common denominator, you need to be able to write each of these fractions in terms of that least common denominator. Well, here's the technique you find a least common denominator. You take your biggest denominator and you double it. And does everything divide into that? If it doesn't, increase it by 6 again and try that. And keep increasing it by this factor until the other two divide evenly into it.
Okay.
So what's the least common denominator?
12.
Correct. Same thing up here. In other words, if I multiply the left side of the equation by 12, I'm getting rid of all the denominators. And if I multiply the right side of the equation by 12, I'm getting rid of all the denominators. What do I have now on the left?
Um, 4x plus 3 equals 12x equals 2, minus 2, sorry.
Okay. Now look at the difference between these things. This is a tough looking equation. This is a ridiculously easy looking equation. And the only difference is I just got rid of the denominators. But I wanted to do it all in one step. I didn't have to. I could have actually done this problem a couple of ways. I could have just gathered all the x's together and gathered all the numbers together. But I still would have had to combine that, and that would have required a least common denominator of 12. So I'm going to get to the answer one way or the other. But whenever I see an equation that has lots of denominators, I always, first step, look for a least common denominator amongst all the denominators so that I can get rid of all of them in one step. Okay? Now, the rest of it's relatively easy. You're going to have 8x over there equal 5, x equal 5/8. Okay. Looking, I think I'm going to have to go past the first couple chapters here because we'll keep the lifting light here. Simplify this expression. And notice it's just an expression. It's not an equation. There's no equal signs.
So you need to distribute the two.
Yeah, they just need you to get rid of the parentheses and combine like terms. So first of all, let's get rid of the parentheses.
Squared minus 2x squared plus 6x plus 6x. So plus 8.
Now combine like terms.
2x squared plus 12x plus 8.
Good. Solve this equation for y. Cole?
Yeah, is that?
Solve it for y. What's the first step?
Subtract the x.
Okay, that's good. So xy equal 1 minus x.
Divide by x.
That's it. Very straightforward. That's what y is equal to. Now we'll make it a little harder. Solve that equation for x. This is not that obvious. This is not that obvious. This is a little, this goes above anything we've done so far today. How are you going to isolate x?
You have to divide by y.
No, notice that doesn't isolate x. If I divide everything by y, I got to divide that by y, I got to divide that by y, I got to divide that by y. I still end up with an x, but I got an x over here. So what can I do to isolate x right off the get-go?
Subtract xy.
No? Factor. Let me say the word factor. That's the magic number here, or the magic term. What can you factor out of the left side? What's the greatest common factor?
X.
Yeah. Leaving?
Y.
What do you get? When you factor something, what you're doing is you're dividing that by x and you're dividing that by x. That's what you're doing. So what are you left with? And it's real easy to check whether you're right or not. Because the very first thing you should do after you factor something is to multiply it back together again and make sure you got what you started with.
X plus y.
Is that what you said?
1. But x plus y, but that.
Well, notice that this is what I need.
Oh.
Because when I factor it back together again, I get x plus xy.
Yeah.
Okay?
Yeah.
Okay, and now, last step. What's the last step here? To solve for x?
I don't know. Like,
Divide by 1 plus y. In other words, when I'm looking at this and I'm trying to solve for x, I got to get rid of everything that's attached to the x. Well, I have a multiplier of the x. It's 1 plus y. So if I divide by that multiplier, that's going to eliminate those, and I'm going to end up with x. Well, I obviously have to divide that side by it also.
So x equals 1 over y.
Yeah, 1 over 1 plus y. Mm-hmm.
Yeah.
Now, let me jump forward a little bit. You've had inverse functions, right?
I think so, yeah.
Well, if y is equal to x squared, what's the inverse of that? How do you figure it out? It's 2 steps. Switch the variables and solve for y. Those are the 2 steps. Well, if I switch the variables, I get this.
X equals y.
Right. And now solve for y. What's y equal to? How do I solve that for y?
Square root x.
Yeah. That's the inverse. In other words, y equals square root of x is the inverse of y equal x squared. But finding inverses is actually quite simple as long as you can solve reasonably hard equations. We'll do an easy one first. Find the inverse of that. Tell me what steps to write.
It would be y squared.
No, switch the variables. That's the first step.
Oh, okay. X equals 3y minus 5.
Now solve for y. That's the second step.
Subtract the 5 divide by. Add the 5 divide by 3.
That is the inverse of that. Okay. So finding inverses is relatively easy until you have a little more difficult one.
Awful.
Find the inverse of this?
Okay, so x equals y plus 1 over y minus 2.
Now solve for y. That's the tough part.
Times both sides by y minus 2.
Okay, read the next line to me.
So that would be xy minus 2x equals y plus 1.
Okay, now what?
Add the 1.
Add the 1 to where?
Just subtract the 1 to the other side.
No, it's not solving for y if you still have a y on the other side. In other words, that looks like it solves for y, but it doesn't really, because then I would have y equals, and one of the terms over here is y. So it's only considered solving for a variable if you get that variable equals and then nothing on the other side is other than the other variable and numbers. So the next step here is to gather all terms with y in it on one side of the equation, everything else on the other.
Divide both sides by y.
No. Gather every term that has y in it on one side of the equation, everything else on the other. Let's move this y to this side of the equation, and let's move this to that side of the equation. That's basically what I said, was gather everything with y in it. Well, there's two terms that have y in it. There's this xy and there's this y. So after I do these two procedures, I'm going to have xy minus y equals 2x plus 1. See that?
Mm-hmm.
Now we're back to a very, very similar problem as we did a little earlier, where if I'm trying to solve for y, what do I have to do on the left side? Always think factoring. If you don't know what to do, think factoring.
Okay.
What can I factor on the left side? Remember, I'm trying to solve for y.
Negative y times...
What's the greatest common factor that I can take out of that?
A y.
There you go. What's left?
1 plus 1.
Start with this term right here. Divide that term by y. What do you get?
X.
Divide this term by y. What do you get?
1.
Minus 1. Now, check it before you go forth. Make sure we didn't change it. Is what we wrote on the left side the same as what we started with?
Yes.
Okay. Now the final step's relatively easy. How do we isolate y?
Divide by x minus 1.
There you go. And that's how you get the inverse of that. And that's pretty complicated algebra. You might not get that for a couple of months into your new year. Only reason I brought it up was because we had to do the same thing on this as we had a relatively simple algebra equation a little earlier. The key is to factor that y out. If you're trying to solve for y, you got to get it all by itself. Notice that I've got y all by itself, and the only thing that's on the other side of the equation are x's and numbers. There's no y over there.
All right.
See if I can find some other good ones here. Give you a geometry problem, but no way. We've been doing geometry for a year, so I think we can take a little bit of a break. Although, you're probably going to take the ACT test in the fall, I'm guessing, aren't you?
I'm taking
Do you have it scheduled already?
It's just going to be, Chatfield is not offering the ACT anymore.
Oh, really?
Yeah. That's all SAT.
So what does that mean? That means you got to take it independently, or are you going to take the SAT?
We're taking the SAT through the school.
Oh, really?
Instead of taking.
So Chatfield's going to, interesting. Very interesting, because Colorado has focused on the ACT for the last 40 years, 50 years.
Yeah. No.
This is quite a move that they're switching to the SAT. Although not surprising, because the new SAT, and I mean new this year, is a lot closer to the ACT. The ACT had 4 trig questions on it. The old SAT had none. Well, the new SAT has some trig questions on it. And it also has a non-calculator portion. So you'll want to be really good with your arithmetic. In other words, you could actually get by and do reasonably well on the old ACT or SAT without having great arithmetic skills, as long as you had a calculator. But not the new one. The new one has quite a few questions on there where you have to know your, you at least have to know your single-digit numbers, positive and negative, all multiplication, all division. And by that I mean, you need to know that 72 divided by 9 is 8. That's single digit to me.
Yeah.
You don't need to know what 11 times 12 is. That's 2 digits.
We took the PSAT in April.
Yeah.
And I got to get a little bit on.
Yeah. In fact, arithmetic skill is invaluable whether you have a calculator or not.
Yeah.
It just is. It's to solve just this algebra problem we had right here. I mean, look at how many simple arithmetic skills we needed. We needed to divide by x. We needed to add 1 and whatever. There are so many that if you had to use a calculator, you'd be so stymied. It would slow you down so much. Hold on, I'm still looking for good problems here. Here's kind of an interesting one we can end up with. Once you master solving equations, you get pretty confident about it. And there virtually is no equation you can't solve. My first step going to be?
Find the least common denominator.
Okay. For all 4 denominators. Or all 4 denominators. What is it?
40.
Correct. So, what am I going to do? What's that?
So it's going to be 10x.
Well, first of all, we're going to multiply both sides by 40. In other words, once you have found that denominator, you still have to apply it by multiplying both sides by it. Now what do you get when you do this multiplication?
On that side you get x plus 15. And on the other side you get 8 minus 8x.
And isn't that much simpler to deal with? So that first step is huge. It takes a difficult equation and immediately turns it into an easy equation. All right. We'll stop there. Have I ever told you about e to the I pi plus 1 equals 0?
No, you haven't.
I haven't given you this? I was thinking about talking about this today. We'll talk about this a little bit next time. Those are the five most important numbers in mathematics. I mean, we're not anywhere near ready to do this. This is a calculus problem. But it's a very interesting problem. And
Yeah.
the fact that e and pi are related in this way. I mean, you know what pi is. E is a very interesting number also that seems to have absolutely nothing to do with pi. I is an imaginary number. It's the square root of -1. But this is like the E equals mc squared of physics. If you were to ask any math person what's the most famous equation in all of math, this is it. It's such a beautiful relation of the 5 most important numbers in mathematics, and totally surprising. Nobody would ever have thought this was the case until somebody went through the math and proved it. But we'll talk about interesting things like this periodically over the summer also.
All right, sounds good.
All right, Cole, I will talk to you next Monday.
Back next Monday.
Bye-bye.